Welcome back. In this video, we'll continue with few more examples on QM method. Here you can see I've given an example, a Boolean function y, which is a function of variables w, x, y, and z, and the minterms are specified here. So we're going to solve this or simplify this given Boolean function using QM method. So as I told, you have to draw two tables for QM method. In the first table, you're going to write the minterms in the order of the increasing number of ones in their binary format. Okay, so first we'll see the minterms and its binary representation. Okay, so we are going to now arrange these numbers in such a way that I have to write them in the increasing number of ones in their binary form. Okay, so out of all these numbers, first I have 1, which has only a single one in its binary representation. So in the first group, I'm going to take 1 whose binary representation will be 0001. Okay. And next, out of the remaining numbers, I have 2 whose binary representation is 0010. 2 also has a single 1. So 2 is done. 3 has 2 ones, so I cannot put it in this group. 5, 9, 12, 14, 15. None of this come into this group now. So group 1 is done, which has only one single one. Okay. Next we'll go for second group, which has 2 ones in it. Starting with the next number is 3, 0, 0, 1, 1. Then we have 5, which has 2 ones. 9 also has 2 ones. 12 also has 2 ones in it. Whereas 14 does not have 2 ones. It has 3 ones in its binary representation. So I cannot put it in this group. We'll have to go to next group. 14, which is 1110. The next number is 15. 15 has 4 ones. So I'll have to go to next group. Okay, so totally I have 4 groups. First group has single one, then 2 ones, 3 ones, and 4 ones. Okay, this is the starting initial table. The next step, again, you need minterms and its corresponding binary representation. Now, how do we write the next column? You have to now compare the adjacent groups and see which two numbers have one bit change in them. If they have only one bit change, then you can combine them and write the output. If it is more than one bit, you cannot consider them. Okay. So we'll start now group 1 and group 2 comparison. First, I'm going to take 1 and compare with all the values in group 2. So we'll see if 1 and 3 can be combined. Yes, there is only one bit change happening here in the second value. So I can combine these two. So 1, comma 3 can be grouped. And after grouping, whichever bit value is changing, replace it with dash. Remaining numbers, keep it as it is. So 0, 0, dash. Okay. And once you have used a particular minterm, you can put a tick in front of it to make to let you know that it has been used already. Okay. Next, compare 1 with 5. So grouping is possible because there is only one bit change happening again. So 1, comma 5. And the reduced form now becomes 0 dash 0 1. Whichever bit is changing, that bit has been replaced with dash. Okay. So 5 has been used now. Next, 1 with 9 is also possible. So 1, comma 9 dash 0 0 1. You have used 9. 1 with 12 is not possible because you have 1, 2, and 3. 3 bits are changing. 1 to 0, 0 to 1, 0 to 1. So if more than one bit changes, then you cannot group them. Okay. So 1 is done. Next, I have to take 2 and compare with all the numbers. So 2 and 3 group is possible. I'll combine them. The answer is going to be like this. So 2 has been used now. Next, compare 2 with 5. Not possible. 2 with 9 is also not possible. 2 with 12 is also not possible. So you're done with the first two group comparisons. Next, you're going to compare G2 and G3. Okay. So first is 3 with 14. It's not possible. You have 3 bit changes happening, so you cannot group them. Next, 5 with 14, not possible again. 9 with 14, no. 12 with 14 can be done. Okay, 1 1 dash 0. So both have been used now. And you're done with the comparison between G2 and G3. So done. Now coming to the last part, G3, G4 comparison. Yes, 14 and 15 can be grouped, and the result is going to be this. So 15 is also used. Okay. Now we have reached the second column. Now to go to the next column, you have to compare. Let's say this is your G1 group, G2, G3. So G1, G2 comparison. I've told you, starting from the second column, it is easy to compare based upon the position of dash. Okay. If you have numbers with same positions, if you have number which has hyphen or eliminated variable in the same position, compare those. Otherwise, don't. Okay. Now, if you just look at the first two group comparisons, 1 comma 3 and 12 comma 14 have this dash in the same position, but when you see the remaining numbers, you have 3 bits changing. So I cannot group them. There should be only 1 bit change happening. Okay, which means there are no similar or there is no group which can be combined between these two groups. There is no number which can be combined between these two groups. Okay. So now if I look at this again, I don't have the hyphen in the same place. So again, this cannot be grouped, which means further simplification is not possible here. You'll have to stop your first table at this point. Okay. So now we'll move on to the second table. So in the second table, I have to list all the prime implicants. Okay. And how do we write the prime implicant? In from the first table, whichever values have not been ticked, those values you have to list here. From this first column, all the values were selected, were used, so don't have to write. But from the second column, none of them were able to be grouped, so you have to write all of them in this prime implicant list. Okay, so starting from first one you have is 1 comma 3. Next you have 1 comma 5, 1 comma 9, 2 comma 3, 12 comma 14, and 14 comma 15. Now write the corresponding equation, okay, for these. Since they've given you the variable as wxyz, you have to write the equation in terms of wxyz. And I've told you if it is 0, it is complement. If it is dash, that variable is not there. If it is 1, you write the variable as it is. So this is wxyz. So for the 1 comma 3, the equation becomes w bar x bar. There is no y, z. So it will be w bar x bar z. Similarly for next one, it is w bar y bar z. Next is x bar y bar z. W bar x bar y. Then you have w x z bar. The last one is w x y. Okay, so you have all the prime implicants. And how did you get this is those which are not picked in or used in the first table that you have to list here. Okay. On the other side, what else you have to write? You have to mention all the min terms given in the question. So here, whatever values are given, no, just mention that M1, M2, M3, M5, 9, 12, 14, 15. Okay, all the values given in the question needs to be considered here. The next step is I have to mark these values as X under these min terms. Okay, so for the first one, I have used, or in this equation, I can say for this term, I have 1 and 3. So I'll put x under 1 and 3. Next it is 1 and 5. So here 1 and 5. Then 1, 9. 2 comma 3. So 2, 3. 12 and 14. 12, 14. 14, 15. Okay. So once you are done with this, the next step is circle those x which doesn't have or which is or you can just look at the column, whichever column has single x, you have to circle it. Okay, If I look at the first column, it has 3. In the second column, there is single X, circle it. Then in the then fourth column, you have single. Then here you have single, and here you have single. Column wise, you have to see which column has single X, you have to circle it. Okay. So once this is done, now you have to take the row value. Wherever you have circled X, that corresponding row equation will be there in your answer. This is also there. This is also there. This is also there. Whichever row has single circled X, that corresponding row equation should be there in your answer. So you have 1, 2, 3, 4, 5 rows, and all these 5 values will be there in your solution. So your solution will be W bar Y bar Z plus X bar Y bar Z plus W bar X bar Y plus W X Z bar plus W X Y. So total 5 terms are there, but this is not the end. You need to confirm one more thing here. Now, out of all the values that you have selected for the final answer, you have to make sure that these numbers are covering all the input numbers given in the question. Okay. So here you have selected this number, right? So 1 comma 5. So 1 and 5 are used. In this value 1 and 9. 1 and 9 is also done. 2 and 3. Yes. 12, 14 and 14, 15. So within these 5, you're able to cover all the given input numbers. So which means this is your final result. Okay. If at all you get a problem where within the final output, whatever you're getting, if they are not sufficient enough to cover all the input given numbers, then there is something else you have to include in your answer. Okay. We'll also try to solve that problem. But right now, for this question, whatever output you have got, you're able to cover all the input numbers with these 5 minterms. So this will be your final answer. Okay. Whatever you have written right now will become your final answer. So I hope this is clear now. I'll just give one more question which you can try it out. But the question is slightly different right now. Instead of giving you the minterm representation directly, the question might be something like this, okay? Y is equal to A bar B C bar D bar plus A bar B C bar D plus A B C bar D bar plus A B C bar D plus A B bar C bar D plus A bar B bar C D bar. Okay, so they might give you the question, equation, full equation, and ask you to solve it or simplify it using QM method. So in this case, what you have to do is first convert the given equation into minterm form, summation M format. And once you get the numbers, the next procedure is same as what you did just now. Okay. So first you have to try and get the minterm form of this given expression. So how to do that? You find out the binary values first. For the given expression, write the binary equivalent. If it is complement, it is 0. If it is original, as it is 1, 0, 0. This number will be 0, 1, 0, 1. This is 1, 1, 0, 0. 1, 1, 0, 1. 1, 0, 0, 1. 0, 0, 1, 0. Now, what is the decimal of this? 0, 1, 0, 0 is nothing but 4. 5. This is 12, 13, 9, and 2. So if I rearrange and write it, I'll get y as 2, 4, 5, 9, 12, 13. This becomes your minterm form. Okay. Now you can continue with the QM method. If you want, you can pause the video, solve it yourself, and then you can verify your answer. Okay. So I'll quickly try to complete this. There is no 0 ones. There is no number which has 0 ones. You have a number which has single one, that is 2, 0, 0, 1, 0. Then 4 also has a single one, 0, 1, 0, 0. None of the other numbers have single one. So this group is done. Next number will be 5, 0, 1, 0, 1. 9 also, 9 has two ones. 12 also has two ones. whereas 13 goes to next group because it has 3 ones. So this is done. Now for the second column, you have to find out the groups which has only one bit variation in them. So compare 2 with all the numbers in the second group. C1. Adjacent groups you have to do comparison. So for I can combine 2 and 5 is not possible. 2, 9 is also not possible. 2 and 11 are also not possible. So 2 is not, you cannot group 2 with any of these numbers. So you have to leave it as it is. Next we'll see 4. 4 and 5 are possible. So 4 comma 5, 0, 1, 0 dash. 4 and 5 are used. 4 and 9 you cannot do it. 4 and 12 is possible. 4 comma 12, which will be dash 1, 0, 0. So 12 is used here. Okay, this is done. Next, compare these two groups. 5 comma 13 is possible, dash 101. You have used 13. 9 and 13 is also possible, 1 dash 01. So 9 is also used. 12 and 13 is also possible, 110 dash. Okay. So again, if next column you continue. So you have to now check. You have to compare these two numbers with all the numbers in the second group. So first I'll see if I have any number which has a dash in the last position. So I have these two. So I can compare these two, and you can see you can combine it because 10 dash is same in both of them. Only the first bit is changing. Only one bit is changing. So you can combine it. 4, 5, 12 and 13. After combining, you will get dash 10 dash. So these two numbers you have used. Then dash in first position, there is only one other value in this group, that is these two you can compare, and you will be able to combine it because there is only one bit change in the two numbers. Dash 10 dash. Okay, these two are also used. This is not done. Okay, this is left out now. Now finally you have same number, further comparison cannot be done. You're going to stop here. Next table, your next table will be having the prime implicants as, I'll just continue here only. Start from the first column, okay? You see which number was not covered. Here 2 was not covered, so write as it is 2. And since it is given in terms of A, B, C, D, this becomes A bar, B bar, C, D bar. Okay, this was not covered. I have used it. Now come to the second table. In second table, there is this term which is not covered. List it out here. 9 comma 13. And its corresponding equation will be A, C bar, D. B is not there. Okay, eliminate it. And both are equal, both are same, right? Write it only once. 4 comma 5, 12, 13. The equation is B, C bar. You have three midterms now. Okay. Now we have to write down the given numbers M2, M4, M5, M9, M12 and M13. So for this I have only 2. Next 9 and 11. Sorry, 9 and 13. Then this has 4, 5, 12 and 13. So if I have to circle single X, here you have, this is single, single, this is single, this is single. Okay. Corresponding row value, second row also is there, third row is also there. So which means, sorry, all the three values will be there in your output. A bar, B bar, C, D bar plus A, C bar, D plus B, C bar. Final verification, final confirmation step is just make sure, since all these three values are there, see if these three values are sufficient to cover all the given numbers. The first value was 2, it is covered. Next you have 9 and 13, that is also covered. 4, 5, 12, 13, 4, 5, 12, 13. All the given numbers are used. So there is nothing else to do. Whatever answer you have written, that is your final solution. Okay. So this is how we can solve any given equation using QM method without don't care condition. Okay. So in the next video, we'll see how to use QM method to solve Boolean function with the don't care. Right? Thank you.